Okay, last bit of trig graphs then. Okay, today we're going to look at trig graphs of the form y equals sine x plus or minus a, or alpha as it is here, makes no difference. And you'll notice that it's in the bracket this time. When it's in the bracket like this, it doesn't change the maximum minimum values, it doesn't change the height of the graph, it doesn't change the period of the graph. What it does change is where it intercepts with your x-axis. Okay, it moves your whole graph either left or right. Okay, if it works a wee bit backwards, if it's a positive number, like this one would be, it moves the graph back the way, so it moves it onto the negatives. If it was a positive number, it would move that's positive twice. If it was a negative number, then it moves your graph to the right. So if we have a look at some graphs, so we have a look at this one here. It's a sine graph. Now, a sine graph would normally start here at 0, go up to 1, cross here, round, and finish at 360. So this whole graph has been picked up and shifted this way. And we need to know how far it's been shifted this way. So our normal sine graph would normally be at a maximum at 90 degrees. This is at its maximum at 75. So it's shifted 15 degrees that way. If it's shifted 15 degrees that way, then it must be a minus, no, other way. It must be a plus 15 because it's moved it in the negative direction. So that graph would have equation y equals sine x plus 15 degrees. The tricky thing about these graphs can be, because a sine graph and a cosine graph are just each other shifted along, is it can either be a sine graph or a cosine graph. You will usually get told whether to make it a sine graph or a cosine graph. This one's a cosine graph. Imagine that would finish it off if I draw that extra dotted line in there. Now, a normal cosine graph starts here, comes down, round, and then would finish here. And it would normally cross the axis here at 90 degrees. But this time it's crossing at 55 degrees, which means it's moved that way again, and it's moved that way by, what would that be, 35 degrees. So that would be y equals cos x minus 35 degrees. Okay, sketching the graph then, I'm just going to go straight to Desmos and let you see what this would look like, and then I'll do a wee sketch of it for you as well. Okay. Do that one. So y equals, I've forgotten what the graph is already, put it back, sine x minus 30. Now if it's sine x minus 30, have a wee think about what you think is going to happen here. Now a sine graph, normal sine graph, add that one in. Normal sine graph would start here at 0, so normal sine graph is the one in red. This sine graph has been shifted along because it's minus 30, so instead of starting at 0, it's starting at 30 degrees. It then draws from there just like a normal sine graph, but it won't quite make it back to 0 at 360, it would take to 390. Now we usually draw a graph between 0 and 360, so we just need to stop our graph before we get there. So our graph, if I draw a normal sine graph in, so normal sine graph, look like this. I'm going to shift mine along 30 degrees, so I'm going to start here at 30 degrees. I'm still going to draw same kind of sine graph. I'm going to stop there though, and then I'm going to extend this line back. So that there will be 30 degrees. Maximum value is normally at 90. 90 add 30, 120. Usually crosses the axis at 180. 180 add 30, 210. Minimum value is normally at 270. Add on 30, it's going to be 300, and it's going to finish here at 360 degrees. Maximum is still 1, minimum is still minus 1. Okay, let's put everything together then. See if we can write down the equation of this graph. So first thing we notice is it's a sine graph, it's starting down, it's going up and then round. It's starting here at 20 degrees rather than at 0. So it has shifted along that way by 20 degrees. It goes up to 2, down to -2. So that must be 2 sine x minus 20 degrees. Okay, and the last one, 2 cos x plus 10. Do a quick sketch of this. What's your maximum value going to be? What's your minimum value going to be? And pretend that's a nice straight line for me. So we've got a maximum value of 2, minimum value of -2, that's plus 10, which means it's going to move back here 10 degrees. It's going to start somewhere up here. It's going to go down to -2, back up and finish up at 2 again. Okay, so 180, 360, 90, 270, and I'll show you that one properly on Desmos. It's 2 cos bracket x plus 10. Do these ones. Y equals 2 cos bracket x plus 10. So here you'll see your maximum value is 2, minimum value is -2. If I change my axes slightly, you'll see these a bit better. Right now it looks like it's still at 2 and it's crossing the axes. So the y-axis, let's make that go down to -3 and just up to 3. There we go. I can see it better now. Oh, didn't mean to do that. Oh, wrong way. So there's our graph there. So you see it starts here. So it's just gone back 10 degrees. It then comes down, round, and it's going to finish just before 360 degrees. It will reach back up to the maximum again here. Okay, and that's trig graphs. Remember, concentrate on naming, don't worry about drawing.